Okay, YouTube, in this video we're going to start to analyze the graphs of functions here. And so there are a few interesting points we need to make before we start analyzing the graphs. But this is like my favorite part. This is just like science class. You just read the graphs. So things that I want to mention here are these. A closed dot indicates that the graph does not extend beyond this point and that the point belongs to the graph. So the difference between a closed and an open dot will be this. The point belongs to the graph, where an open dot is going to indicate that the graph also doesn't extend beyond that point, but also that that point does not belong to the graph. So it might be the case, and it's not the case on this graph right here, but that I have a big fat open dot right in the middle of my graph, which would mean at this data value, we don't have the data. That's all that would mean, okay? But we usually put open or closed dots on the endpoint. So if I were to put an open dot here, basically I would say that it's all time up to 11 years, but not including the 11 years though. Okay. Now the last thing I want to mention is this. An arrow would indicate that the graph extends indefinitely in the direction in which the arrow points. So this graph over here has no arrows, but of course that's how we recognize them. So I do want you to see this graph. We will actually stop and analyze this a little bit here, but it says the T cell count and HIV infection. So you can see that as the number of years goes by here and that this person is infected with HIV, you can see that the average T cell count per milliliter of blood drops rapidly at first and then seems to peak here. This is called the asymptotic stage, where there are few or no symptoms present, but then it just continues to diminish. We call this blue portion of the graph the symptomatic stage, where symptoms begin to get worse, and then we have the AIDS clinical diagnosis at the end here. So what I want to do with this graph is explain why f represents a graph of a function. And the first thing I would mention here is that it is, I'm going to take the cheap way out here, 1 to 1. We could also say it passes the vertical line test, but for every unit of time, there's only one output or one data point for the average T cell count in the blood, okay? So we'd say this is a function because it's 1 to 1. Also, let's use the graph to find f of 8. Now, what I know is f of 8 basically means find y, or the function value, when x equals 8, or in this case we could say time equals 8, t equals 8. But basically we're saying find the output at this given input. So using the graph, what this means is we're actually going to have to go find that input value, trace it up and over, and I see that it kind of looks like it hits right on this cross point here with my grid. So if we trace this over, I would say that f of 8, just by using the graph, we would say that y, or f of 8 here, would be approximately equal to 200. And I should write approximately because I can't be certain, but I'm pretty close. I'm pretty sure I'm pretty close. And then it says for what value of x is f of x equal to 350. Now the interesting thing here is that we're given a y value and we're asked to find then what is the input. So 350, if you look at our graph here, we could essentially say, well, here's 300 right here. 350 would be kind of halfway between here and 400. So if I trace this out over on my grid, what I'm going to do is I'm going to try to get my best guess, best estimate. And what I could say is x would be approximately equal to 6 years. Okay. So the last part here says describe the general trend shown by the graph. Well, what we can see is the general trend is that we have a downward kind of progression here. So we would say that the graph is generally decreasing. Okay, is it always decreasing is a question I want to know. And what we can see is that there was actually a portion of this graph, if I said when was it increasing, and the only time it was increasing was between about a half a year and a year after the infection. So we would say it's increasing from here to here, but everywhere else we have a decreasing graph. But we're going to be using these concepts a lot to interpret graphs. Cheers.